Hey there, it's Jason from Codemanship with another video in my series on using AI assistants in software development, specifically ChatGPT and GPT-4, OpenAI's latest version of their large language model. Now, I've done a bunch of videos already. If you want to go back and review those, I highly recommend. And I've thrown various sort of tasks at GPT-4. Doing test-driven development in two different distinct roles where I was navigating, telling it what to do, and it was writing the code, it was driving. And I did it again where it was navigating and I was driving. Those were interesting sessions. I've done some refactoring of legacy code with it and writing unit tests for legacy code. I've attempted to create a web UI from wireframes with it. That was my last video. And I wanted to sort of spend just a little bit more time on it and go through a session I had with it over the last few days where I wanted to see how it handles sort of complex business rules where there are lots of possible combinations and permutations of different inputs, if you like, different factors, and see how it gets on with that, see how it, in inverted commas, wraps its head around that kind of problem. As we'll discuss later, it doesn't wrap its head around anything. That's not what it does, and that's not how it works. But to see how it got on with this. So I invented a problem about calculating shipping costs for orders, and we had a bunch of business rules. I thought, let's start with 3 of those rules. So inside the UK, standard shipping by Royal Mail is free on all orders over £10. Outside the UK, standard shipping is £2.50 on all orders. Next day delivery is £5 on all orders. Okay, off it went. Generated some not particularly attractive and very heavily commented Python code. Now I'm going to make an observation here because I've done some C# with it, I've done some Python, we've done some HTML and JavaScript. And what I've noticed and what I picked up on with the many hours I spent with it so far is how it codes. The kind of code that it will write depends quite a lot on the programming language you choose. For example, when we were doing test-driven development in C#, it was writing comments in each test, arrange, act, assert for the setup, the action, and the assertions. But when we were doing TDD in Python, it would use given, when, then. And there are all kinds of examples of how it will do things differently in different languages. It comments nowhere near as heavily in Java and C#, for example. But in Python, it comments a lot. You get very procedural code in Python. I've noticed, but when you work in C# and Java, you tend to get code that is by default object-oriented or leans heavily in that direction. So I think in the same way that sort of developer communities have a kind of a culture about them, there's a sort of a culture about front-end JavaScript developers, for example, that is in many ways different to the Python culture, which is rooted more in scientific computing and in data science and machine learning and those kinds of things, where the standard of code craft, if you like, tends to be a lot lower. And as we can see, this is a pretty low standard of code craft. But anyway, I thought, let's go with it. Now, at this point, I thought what I should have done, what I would normally do, is say, okay, well, let's copy and paste this code into a PyCharm project. Let's run it and see what happens. But I didn't. I thought, let's just keep going. So I gave it another 2 rules. Outside the UK, next day delivery is not available. So that's not a valid delivery method in the EU or outside the EU, for example. Inside the UK, recorded delivery is £7.50. Okay, so Julie, off it went again, wrote some even gnarlier code with all kinds of nasty things going on here, primitive obsession, nested ifs, multiple layers deep, non-helpful comments and API documentation and stuff I did not ask for. But off it goes. I just let it do its thing for now. And again, it gives me some advice on how to run that. So it's assuming that I'm going to test it manually at the terminal. Okay, and the final 2 rules: outside the UK, recorded delivery is £10 in the EU and £15 outside the EU. In G20 nations that are in the EU, a discount of 10% is applied. In G20 nations outside the EU, a discount of 5% is applied. So that last one, yeah, you may have guessed, is a little arbitrary. doesn't really make any sense. But I thought let's add one more combination of inputs to make it a little more interesting. And off it went. And as you can tell, with two more rules, the if statements got deeper. We got a dictionary there. All kinds of stuff going on, and also, and it does this. It does it. Maybe it just does it with me because people say to me, "Oh, I went to the prompt and said make me one of these applications, and it generated all of the code for me." Won't do that for me. It'll generate sort of like a skeleton of the code sometimes, and then put in a placeholder and say, "Oh, you can do that. You can do that part," and then I have to tell it explicitly, "No. How about you do it?" Me boss, you employee here, you worker, you're the one who's getting paid $20 a month, a princely sum, although that's probably roughly what a lot of people employed by OpenAI get paid in Kenya, for example. Anyway, so we listed the G20 nations, and it's a reasonable looking list. There we go. And we look down there on the list, and it looks fine, but this is another thing that I've commented on multiple times in these videos. There are things that you should not trust GPT-4 with. You should not trust its arithmetic. It's really bad at it. Really bad at it. Worse than a 5-year-old, really. And you should not trust data. So if you ask, for example, a list of all the G20 nations and it needs to know whether or not they're in the EU, it seems to think that the UK is in the EU. Now, famously, unless you've been living under a rock for the last 7 years, famously, we have left the EU. So we're no longer in the EU. Now, I can't remember when, I think we finally left. I think the transition period ended. It would have been at the beginning or the end of 2021 or beginning of last year, but we were still technically not in the EU. It was just a transition period. But anyway, so I had to point that out to it. The UK is not in the EU. It fixed that problem for me, and I thought, okay, we'll go with that. That looks reasonable. But bearing in mind, whenever it generates this kind of data for you, double check it. So I did go to Wikipedia and just look and go, what are the countries in the G20 and what are the countries in the EU? So double check it. Okay, right. Which kind of negates the value you get from something generating this code for you, because you're going to be looking it up anyway. I asked it at this point, so I wasn't entirely happy with the code, particularly these nested if statements. So I asked if it could refactor the code to use fewer conditionals. Now, very often in code, when you see conditionals, if statements, switch statements, that kind of thing, they're really just mapping. They're mapping strings onto other strings or numbers onto other numbers or type codes or enums onto actions and so on and so forth. And there are more dynamic ways of mapping. For example, you could use a dictionary, and that's exactly what it did. It went to use dictionaries for a lot more of this. So our if statements are not looking quite as bad. This is still a really long function. Still a way lot going on here. And just a reminder, we still haven't tested it. So I still don't know if this works. Now, in the real world, I would not do it this way. I would not give it 7 business rules all overlapping and say, write me that function and now refactor it without any automated tests. I would give it 1 business rule and we'd agree an example or 2, and then we'd test drive some code, check that that works. So you would be taking small steps, baby steps, with continuous testing if you're using GPT-4 on real software. And that negates a lot of its value. It really does, because if you actually want to know if it works, and if you want the code to be easy to understand and easy to change, a lot of the value in you type in a prompt and it generates an app for you. A lot of that value is lost. Not if you have specific requirements like these business rules, and not if you want to be sure that it works. Then things really do start to slow down, and then you realise that most of the work is not the typing of the code or looking things up on Stack Overflow. But anyway, that's for the final video. Anyway, I'm still not happy with it. Can we go further? Can we do more of it declaratively? At this point, I think it took declarative to mean something else. So it did something that I didn't quite understand what it was doing and why that was declarative, but there you go. But it eliminated some of the if statements. So we got a little closer to something I might be happy with. But I thought I'll just qualify. try doing it using filter, map, and reduced. At that point, it kind of got what I meant by declarative, like functional programming style. So it had a go. It warned me that this might make the code harder to read. I'm not sure you could make it much harder to read, to be quite honest, but it did manage to make it harder to read. There you go. So go down there. We're using next and filter. Lots of different ways it could have done this using these dictionaries, but it's all still looking to me pretty nasty. I've created a couple of internal functions there to sort of help, but on the whole, it's just looking a little nasty still. But at this point, I just wanted to know whether or not it works. So I asked it if you could please. Oh, actually, no, there's something I should mention here. As the code listing gets longer, as the outputs get longer, it often will just kind of run out of steam. I think whether there's a character limit or whatever it is, and it seems to be variable. Sometimes it happens, sometimes it doesn't. Sometimes you could just tell it to keep going, and it will continue. If it sort of stopped because of a character limit, it will kind of continue. In fact, at one point, it advised me that it could do that. But in this case, it just kind of fizzled out down near the end. So I said, keep going, and it did it again, but this time it managed to give me a complete source listing. Okay, now, before I asked it to generate tests, I was, at this point, very curious about something. Just how far back in terms of programming languages can we go? For example, Smalltalk 80. How much Smalltalk 80 code is there sitting in GitHub or on Stack Overflow that it could learn from? And therefore, would it be really bad at it? Would there be lots of gaps in its model relating to older programming languages like Simula, for example, or Fortran 77 or whatever? So I decided to get a little ambitious here. I was very curious about this. I don't know if you've ever come across a formal specification language. So in software development, formal specification is precise, unambiguous, a specification of what we want our program to do. Typically in some kind of language that is like a programming language or is mathematical in nature. There is a formal specification language, a notation called Z. And it's object-oriented sister, if you like, object Z, that is based on first-order logic and set theory. So it's mathematical in nature. And I wondered, could you actually specify this function using Z? So I asked it, and off it went. And I was very surprised. So now my Z is very out of date. I did use it a long time ago. So I would have to sit down with my book on Z to actually wrap my head around this and make sure that it really does make sense. But I will make an observation. A lot of the names it's changed. So the names in the code, for example, they don't match, like order total, country, delivery type, etc. But there you go. It looks, this is the thing about ChatGPT, based on my recollection of Z notation, it looks plausible. It looks plausible. Whether it's actually correct or not, I would have to spend some time. And this is the problem when people are saying, "Oh, we won't need programs anymore," because you'll be if you need something in an Excel spreadsheet, or if you want a website with functionality on it, you can just sit down and describe it to. GPT-4 or GPT-5 or whatever version comes next, and it will generate the whole thing for you. What I'm discovering is, one, no, it won't. You have to kind of nudge it to do that. Two, if you don't know what it is you're looking at, you're taking a big risk here, just copying and pasting this stuff into files and running it and deploying it. So again, much testing is required. I think, from my recollection, this is Z. But I would have to double check it. And I frankly cannot be bothered because there's not going to be a lot of point in doing that. But it did get me to thinking, how much does the amount of training data available impact how good GPT is at writing code in that programming language? And so if you go further back, or if you go for languages that are not widely used, like Z, for example, how good is it really? But anyway, it looks plausible to me. So I thought, okay, that's very interesting. Very interesting. So at this point, I got very ambitious. I started to believe the hype. I started to believe that there really was a Wizard of Oz, and that there wasn't just a big statistical model sitting behind that curtain. So I asked it if it could do a proof of correctness for this for the Python code based on the Z specification. That's one of the things that you might use a Z specification for. Now, proof of correctness is a mathematical proof that an algorithm or some program code will satisfy the specification in all allowable instances for all inputs. For example, you may remember from school when you did maths, you might have learned about proof by induction, where you show that something works for a value k, and then you prove that it works for every k plus 1 value, that kind of thing. So I was curious to know if it could do it, and as you could see, it couldn't. Nope. What it was able to do a little bit was to correlate parts of the code to parts of the specification. Now, this is in the code and it's in the specification, which is by no means a proof of correctness. So the answer to that one basically is no. But I shouldn't be surprised because it's a language model. It doesn't do that kind of thing. So moving us swiftly on, talking of proof that it works, give me some unit tests basically based on that specification. So it dreamed up some combinations of UK, EU, outside EU, standard delivery, next day delivery, recorded delivery, in the G20, outside the G20, etc., etc. It came up with a bunch of different combinations or permutations of those different factors, those different inputs, and I ran those tests and they all failed. And I gave it one example of why they were failing. So it went, oh, I apologize. And we went through quite a long conversation where it would fix the tests or fix the code, fix the implementation. And then I would run the tests and they would still all fail. And it would try to fix so it fixes the implementation here. I run all the tests, they're still all failing. All the assertions are failing. And we went round and round in these circles for quite a while. And then it started to do strange things. This is the thing about when I talk about not understanding. So I know that these variables here are not visible inside this inner function here, discount key, because they're declared in the outer function. So they're not really visible. So it didn't seem to understand that. So I don't know, actually in Python, should they be visible? I don't think they are. But anyway, according to the compiler, according to the Python runtime, they were not visible. It was throwing up syntax errors. So we kind of went into a conversation, and I said it's not visible to the discount key function, and so it said, oh no, it is. It's right out. That's what it is. It's not an inner function of calculation. I think if it was an inner function, they would be visible, but it's outside. So it took them outside, and it's still referencing these variables, G20 EU countries, G20 non-EU countries, that are defined inside the calculate shipping function. So they're still not visible. Still has the same problem. Again, it tried to fix it without understanding what the problem was. So eventually I had to tell it. The problem is that discount key references variables that are local to calculate shipping. In other words, it can't see them, at which point it went, oh, you're right, and then it fixed them. Now, I found this really, really interesting because it didn't really get that. When it was looking at the code, it was not building a model of the code that says, and that's visible to that, and you can call that from there, and then that's private, and that's public, etc. It doesn't seem to do that. So it didn't seem to understand until I told it precisely what the problem was. Okay, so a lot of people have said, oh, it's really good at debugging things. And I found on occasion you asked, what's the problem? And it's gone straight to it. But I've also found on multiple occasions, it's looked and it's looked and it's tried to fix and it's tried to fix, and it's just not seeing what I'm seeing. It doesn't have the same internal mental model of the code that I do. In fact, it doesn't seem to have an internal mental model of the code at all that include these concepts like visibility, scope, and so on and so forth. Anyway, it fixed the problem, but now started to introduce lots of new problems. For example, where did all our EU countries go? I could have sworn there were more than 3, and there were definitely more than 2 non-EU G20 countries. So then we got into a long back and forth so for example, I sort of pointed out where all the complete list of G20 countries. So this is where like I said, double check the data. So it looks plausible, looks plausible, looks plausible. Luxembourg, Cyprus, Estonia, Latvia. This is just a list of EU countries. But now the United Kingdom is back in the EU. Hurrah! If only that were true. So this is where the code, its version of the code, my version of the code start to drift. Its facts start to get very dodgy. We went round in these circles for quite a while trying to get these lists back, and I couldn't do it. So eventually I sort of gave up and said, okay, fair enough. The United Kingdom is in the EU. Let's just go with that, shall we? And so I thought it would be a good idea. Now, I found that this is a good idea anyway, to, on a pretty frequent basis, actually, remind it of what the actual code is that you're working on. Because, as I said, its model and your model will drift. And you will reach a point, as we're about to, where it just forgets what we were working on. Anyway, it started to drift, so I thought, let's bring it back. Okay, here's the actual code as it is now. And that sort of brought us back into the fold. We still haven't fixed the bug. Yeah, we still haven't fixed the bug or the bugs, or whether it's in the tests or whether it's in the implementation. All our tests are still failing. It keeps trying to fix the bug. It keeps trying to fix the bug. It keeps trying to fix the bug. Okay, so I'm like, well, I better show you the test code then. Right, okay. It then fixes the code. Okay, and at that point, we hit the interaction limit. So with GPT-4, if you're not aware, there is a limit of 25 interactions with it within a 3-hour window. And we hit that limit. And when we hit that limit, all of our tests were still failing. Its version of the code was drifting away from mine. It wasn't able to fix it. It couldn't see what was wrong. I knew what was wrong, which is very simply that its arithmetic was wrong. But also, it had created a rod for its own back. Its implementation, let's just quickly show you, its implementation was just too complicated. Just too complicated. And we were never going to get this to work. It was never going to get this to work. So we kind of left it there. I had no choice, really. I'd run out of tokens, quite literally. And I thought, well, I'll sleep on this and I'll come back to it tomorrow. So what I did the next morning, because I really have no life at all, what I did the next morning is I got up and I basically, from scratch, wrote my own version of the shipping calculation. And I did mine object-oriented because I tend to move in those circles. So we've got a bunch of objects that represent these concepts. And hopefully what you can see is it has greatly simplified the logic. Greatly simplified the logic. I can now see the wood for the trees. So I have a reasonable amount of confidence that this will actually work. Now, if I've been doing this for real, I would have done it test-driven. I would have done it one business rule and one example at a time. But I didn't. I wrote it entirely from scratch without any test at all, because what my goal was for the continuation of my session with GPT-4 was to get it to write the tests based on this design. That's what I wanted to see it do. Now, I'm going to make an observation here, first of all. It was the best part of an hour and a half with GPT-4 in the first session, and we effectively got nowhere. No working code. At the end of it, we had no working code. We had code that was difficult to understand, that was too complicated, and didn't work, basically. If we'd done it in small steps and tested as we'd gone, we might have ended up with something that worked. Might have taken us longer, I don't know. But I'm going to make this observation. I wrote this code it was about 25 minutes in total that it took me to write this code, without tests, I should stress. And so I was able to create what I believe is a complete implementation. It did have a bug in it, but we eventually did discover it in a fraction of the time. A fraction of the time that it took GPT-4. Now, if I've been really disciplined about it, it might have taken me an hour. But it's still a fraction of the time to produce something that works compared to trying to do it with GPT-4. And that's been my experience with GPT-4 so far. In pretty much all of these sessions we've had, I've got to the end of that session, I've looked at my watch, and I thought, you know what, I could have done this faster myself. But but that's only because I'm measuring my productivity by working software, working clean, maintainable code, stuff that you could ship, that is ready to ship. That's how I measure my productivity as a programmer, not as a developer, because obviously there's a much wider process that goes on there that involves things like customers and production and stuff like that. But in on the programming side of things, I measure my progress in terms of producing working code, producing working software that is easy to understand and easy to maintain. And in that respect, I am faster without GPT-4. I'm pretty sure of it now. That and the fact that GPT-4 currently doesn't scale to the levels I would need it to in terms of the size of the problems that I would be working on. It just can't handle it. You hit limits in terms of tokens, the context window, you hit limits in terms of interactions, but you also hit, I think, what I genuinely believe are fundamental limits of large language models as well, regarding things like factual accuracy, things like conceptual understanding, like, for example, visibility of variables and stuff like that. So you're going to always end up spending your time working in those baby steps, constantly double checking everything that it tells you. If you don't understand what you're looking at, if you don't know Python, for example, I am highly skeptical that it could really genuinely build you a complete Python application of any appreciable complexity, particularly if your requirements are very specific, like these very specific business rules. Okay, but it can give you a Z specification for the whole thing, so that's good. Anyway, moving on from that, I completely rewrote it, and then I took that back to GPT-4 to continue our session. So there's the new code I said, nice and object-oriented. And it says, I see you've refactored the code to make it all object-oriented. Now, this is something else it does. Let's just scroll back to the beginning of this. I refactored the code to make it more object-oriented. I see that you refactored the code to make it more object-oriented. You bought a lawnmower. Would you like to buy another lawnmower? So we're in that sort of territory of AI where it's just stating the bleeding obvious, basically. Not particularly helpful. It means I spend a lot of time reading things that I've just told it. And I really wish that it didn't do that. So anyway, here's a test suite that covers the original test cases using your new design. So off it goes. It generates a bunch of tests. I think, looking at that and I was going through them and thinking, that looks like a reasonable set of combinations of factors here. Maybe possibly not them all. In the real world, I might sit down with a spreadsheet and do something like a decision table or response matrix or something like that to see if there's any combinations or cases that we might have missed. But anyway, I think it made a reasonable fist of it based on the code that I gave it. Remember, it is generating these based on the code. So its understanding of the problem now is based on the code, really. And I'm not a big fan of generating tests from code. I think ideally when we write tests, they should be based on requirements. And the code should do what the requirements say. That's, of course, if you've got a set of requirements. You can always go ask someone. Anyway, I ran the tests. It helpfully suggests that I run the tests. Thank you for that. So I ran the tests, and we got a bunch of them failing. 7 of them failed. I pasted in the output from the console with all the failure messages, and it went, oh yeah, okay, basically maths again, arithmetic. It can't do it. So many of its expected values were wrong. So I went back and fixed a bunch of them, gave me some new test code, for which I was grateful. And then that was a big step forward. Then we had most of our tests passing, I think 11 tests passing, 1 failing. So one more bit of arithmetic to fix with a result that was an expected result that was wrong. It fixed that, and hurrah, hallelujah, now all our tests are passing. So now we're in reasonably good shape. We've got a much simplified implementation that's much easier to understand, much less likely to be wrong, and we've actually got it working. Okay, although as we discovered, there are gaps in our tests. Okay, now, because I wanted to make this a bit more real world, it's just a very weak indicator in the sense that it tells you which code is definitely not being tested. But I do tend to keep one eye on coverage. So every so often I'll just run a coverage report and go and look for the red, basically look to see which parts of the code are not actually being tested at all. And because I do test-driven development, those are usually small, but often not zero. And in this case, we had 7% of lines of code in our implementation not really being tested. So I asked it if it could have a think about which lines of code we're not covering and how we could improve that coverage. It noticed that we're not actually testing the exceptional case where, for example, if you try to select next day delivery in France, that's not allowed. It's only available in the UK. So you should get this exception, this delivery method not available exception. And we did not have a test case for that. So it added that test case, which is pretty clever, I thought. And that test was failing because we weren't actually. This is why you need to keep an eye on the level of test assurance, what's really being tested, because in actual fact there was a syntax error. Again, Python is a scripted out language. It doesn't compile it and go, that's wrong. But when it actually tried to create an instance of our custom exception class, it went into the constructor and found a syntax error, basically. So I said, look, this is what's happened. It fixed the syntax error for me. Thank you very much. And that took our coverage up to 90% of the code, which I was quite happy with. There was one part of the code where I had an abstract base class. Now, Python doesn't directly support abstract base classes, and it doesn't need to because you have dynamic typing, duck typing. But it can be useful sometimes to document the fact that you've got a bunch of classes that are all supposed to conform to the same contract. So you might want to define that contract in terms of an abstract base class. So there is a helper library you can use called ABC, abstract base class, to denote classes as abstract base classes, to denote methods as abstract, and so on and so forth, which essentially tells the compiler, no, you're not supposed to be able to create an instance of this. And of course, if you can't create an instance of it, it's not necessarily going to be tested. If you've got methods that are abstract, they're not actually, the contents of those methods are not going to be tested. So that was accounting for the remainder of our missing coverage. So I was reasonably happy with that. 97% code coverage is very respectable, even for me. But then I went on, because at this point there may well be people, you maybe were sitting there thinking, yeah, but just because you got high coverage data, that doesn't mean that everything's really being tested, and you would be absolutely right. So to sort of round up the session, what I wanted to do is to take GPT into new areas. So we started to have this conversation about, just because the test coverage is high, does that mean the code really works? And it said, no, not necessarily. And it gave some good examples there of potential blind spots where our tests might not be really be testing things. For example, external dependencies, you might want to include integration tests, incomplete test cases, all that kind of stuff. So there may be gaps in the combinations or the permutations of different inputs, for example, that we're not actually accounting for, that are not being tested. And then it gave some suggestions about code reviews, static analysis, integration testing, production testing and monitoring, that kind of stuff. All good advice, by the way. But I was kind of hoping that it would come up with one particular suggestion that I'm surprised was not in the list. Remember, this is just autocomplete or predictive texting on a massive scale. So if you ask it about the relationship between code coverage and test assurance, it will go blah 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 blah. This is what I've been trained on. So I wanted to sort of nudge it a bit. You find you have to nudge it quite often to think of a simple way of checking if our tests are really testing the code. And I was very pleased when it suggested, well, what we could do is mutation testing. We deliberately break the code, run the tests, see if any tests fail, basically. And if you can break a line of code and no test fails, even if that line of code is being executed by the test, does that really mean that it's being tested? So you might have a gap in your test. So we went down that road, and it even made a suggestion as to a couple of Python mutation testing tools, one of which I've used in the past, MutPy, and Cosmic Ray, which I've now got on my to-do list. That's one I'm going to use at some point in the next few weeks. So I thought, well, I've used MutPy, let's go down that route. I needed some reminding. It's been quite a while since we've done any training with MutPy. So it gave me some instructions on how to install it, how to set up your project so it knows where to look for tests and source code, and how to run it from the command line. Now, I had a problem with I still have a problem, which I've got to look into and fix before training next week, with running things from scripts from the command line, from the terminal window in PyCharm. It just doesn't seem to do it for certain things. So when I ran this, nothing happened. It turned out I can actually run it from the IDE itself. So in fact, I can show you that. I can set up a run configuration for MutPy. Let's edit that configuration so I can show you. Basically just copy and paste the command line arguments into the configuration, and I can run it from here. So it runs from here, and it runs pretty quick, as you can see, and we get some interesting results there. My current mutation score is 100%, by the way. That's no thanks to GPT-4. So I can run it. I will mention it, but nothing to do with what I'm talking about now. But I will mention, so I'm on a fairly new version of Python, 3.10, basically. And what seems to have happened at some point with versions of Python is that the Python runtime, some of the Python libraries have changed, particularly for threading. And some bright spark, this happens a lot in the Python world, in the JavaScript world, in many other worlds, some bright spark decided, so this is a method of this base class called thread, which is from the core Python libraries. And some bright spark decided, it was originally in non-Python standard naming convention. So it is alive in a kind of Java style, if you like, or a C# style. And someone decided, no, we need to make that Python standard. Which of course breaks a bunch of stuff. So at some point, MutPy stopped working. So you can hotfix it. It's part of the libraries. You can hotfix it, and that's what I did here, so that it actually does work. But it is annoying. I mean, you can blame the people who develop these open source tools, but it annoys the heck out of me when people put in a lot of their own time, often for no money at all, for no real reward, other than helping their developer community, like with tools like MutPy, for example, and then they're building on quicksand. The dependencies, the libraries, and so on, and frameworks they're building on kind of drift over time. And eventually something that you had working, that you put all that time and effort into, suddenly stops working. So on later versions of Python, I'm not sure exactly which version of Python this problem appeared, but in a later version of Python it doesn't work, and I have to hotfix it to make it work. As I said, there's also a problem with running it from the terminal. Don't know why that's not working, but I'll need to get that working for next week when I've got some Python training on. So anyway, that's all very, very interesting. So we have our tests. We had a mutation testing report from our original run. So I pasted the contents of that report after much toing and froing about why it wasn't working. We eventually got a mutation testing report. And just to go through this quickly, basically it's showing you, if you tell it to, it will show you the code that it's mutated, and this sort of minus plus. Minus is what it was before, plus is what it got mutated to. So it took that line of code and turned a plus into a minus, and it's saying no tests failed, so that's obviously a problem, unless it's plus or minus at 0, of course, in which case it's logically equivalent. Need to watch out for that with mutation testing. Yeah, there when we've got a times and a divide, and so on and so forth. So we've got a bunch of surviving mutants, a bunch of mutants that are surviving. So it would suggest that our tests maybe have gaps. And I asked GPT, so we got a score at the bottom here. There's quite a lot of information there, but we get a score at the bottom. Let's just scroll down to that. Okay, right, yeah, so mutation score 57%. So it did 19 mutations. Our test suite killed 8 of those mutations. In other words, a test failed. 6 of them survived. I'm not entirely sure what incompetent means. I think maybe it means that the mutation is logically equivalent. In other words, no test should fail. Don't know what that means. I've got to look into that. Looks like it's a new thing. Maybe not. Maybe I've just paid no attention to it before. But anyway, it went through and said, here are the results of the mutation testing. A total of 18 mutations were generated. No, a total of 19 were generated. Um, 10 were killed by the tests. No, 8 were killed by the test. So it's starting, having literally just given it the mutation testing report with the results. It's now making up its own results, including, if we just go back, its own mutation score. It's literally just making it up. And I'm guessing it's because it's not been trained at all on MutPy results or mutation testing results generally. That would be my guess, that it's not seen a lot of this. And so it doesn't really know what to do with it. So it started hallucinating, basically. I think if its model of languages, some people have likened it to a big cheese. It's like a Swiss cheese with holes in it, and we're in a big hole here. It really doesn't know what I'm talking about here. So it makes a bunch of stuff up, and I'm very curious at this point as to how it would fix those. So it looks at the various mutations. Again, it's making them up. It's inventing them. And at this point, it's inventing things in the code. So it thinks there's a local delivery class. There is not. Delivery method has no get country rate method, I have to point out. So it's hallucinating. It seems I provided incorrect information about the gaps in the test. So now it starts giving general advice about what to do if there are gaps in your tests. I gave it a complete source listing. Have you forgotten it? So I gave it the current code again. So we're back in forgetful territory here. And I gave it the test code. Okay. Thank you for providing the context. I will now analyze the surviving mutants in the context. At this point, it is making up mutations. Okay, this style of mutation change calculation logic, blah, blah, blah. So we get into that, we get into it, 6 mutations. Could you write more tests? So I'm curious at this point. If your interpretation of the mutation results is correct, what tests would you write to improve that score? So it adds some more tests, which I duly copied and pasted into the code. One of those tests failed because it done something very weird with assert not equal, and it was returning an actual number. And it tried to fix it, and I tried to make it specific because it was saying the cost should not be 0, and I would prefer the test say what the cost should be, not what it should not be. So I got it to change the test to say what the shipping cost should be in that particular test case, £2.50 in this case. Okay, so at that point all our tests were passing again, but our coverage report only improved very slightly, made very little difference to our mutation coverage. Okay, so I gave it the results again, which it had already seen multiple times. And let's keep scrolling down. It's quite big. Okay, and again, total mutants 18, killed mutants 10, survived mutants 5, incompetent mutants 3. So again, it's just making up its own mutation report and its own results here. The survived mutants are, none of these mutations happened. It's just making them up. But I was curious as to, we had a conversation about the abstract method and the abstract base class, and then it went on and said, well, you might want to test it, you might not. In this case, I don't think there's any real need to test it. So if we excluded those mutations that relate to it being abstract, then what survives, basically, if we remove those mutations? What's of interest? Okay, back in again. Conditional mutants, changing the logic conditional statements. So again, we're getting back down to sort of general advice. It's not going to write any tests for me. Okay, so I'm asking it from the actual mutation testing report, which surviving mutants remain if we exclude mutations. And at this point, it starts lying to me. It's telling me it's not seen the report. That it has no ability to look at mutation testing reports, and it starts trying to give me general advice, so I stop it. I just tell it I just gave it the contents of the report, and it tells me again it doesn't have the ability to look at the contents of files, reports, or any other form of input apart from the text you provide in your messages. So I think I hit a big gap in its model, basically. I think when it comes to interpreting mutation testing results, it knows nothing. And I wonder what other sort of tool outputs or command line outputs, it doesn't understand. It has no real knowledge of, or very little knowledge, that it's just going to start hallucinating. But I fixed the problem. So I read the mutation testing report, took a look at that, and I went back to my code and said, well, look, we don't really need that abstract base class delivery method. So if we get rid of that and use duck typing instead for our next day delivery, standard delivery, and recorded delivery, as long as they've all got the same interface and work, the same from the outside, that should work. So I did that. That improved our mutation coverage a lot. And I also added a test that checks to see what the actual exception message is when we select an invalid delivery method. For example, next day delivery in France. And when I did that, when I made those changes, as you can see, our mutation score went up to 100%. Just going down there, we've got 2 incompetents. In other words, 2 that it deems to be, I think that's what it means. Two mutations that are deemed to be logically equivalent to what we had before. So false positives, if you like. So it gives me a score of 100%, which I'm happy with. So now I'm confident that my code is really being tested. And if someone were to break this code, one of these tests would fail. Okay, so that was my final exploration for now with GPT-4. I'm going to record one final video, so I'm not going to go through any of these sessions, but I'm going to record one final video where I'm just going to offer my final thoughts on my experiences working with GPT-4, on the use of tools like this and AI in general in software development, both for myself personally, but I'll also talk about some of the teams that I work with who are using tools like this, or Microsoft's Copilot, the GitHub Copilot, and I'll make some observations there as well. And I'll do a little bit of background reading, a bit more background reading, and I'll have a little think about the future and how enthusiastic I am about the possibilities and how optimistic I am about where this is going to go, where this is going to end up. On the whole, I'm pretty perky about it. I will offer you that spoiler. I'm not, oh, woe is me. I don't think this is going to spell the end of our profession. Far from it, in fact. But we'll discuss that in the final video. Anyway, I hope that's been of interest. You take care.